Welcome to the 1985 Nobel Prize in Physics, which actually went to Klaus von Klitzing, a slightly German fellow, if you can imagine that. Um, he discovered what's known as the quantized Hall effect. He discovered this in semiconductors. All it really is a big fancy way of saying when you apply a voltage is generated in a conductor when you apply a magnetic field to it. So if you put an E&M field across a conductor, if you do it properly, you can actually get a voltage to be generated out of that conductor or semiconductor, depending on your application, which is pretty cool. I mean, you look at it, you say, hey, look, I can apply a field. I don't really have to touch it. That field can actually just kind of be in the presence of this thing, and you generate some electricity out the other side. You're going to spend more money, more electricity generating the field than you're going to get out of it. I get that. But it actually has some really cool applications. So you can actually use it to build sensors. And those sensors do all sorts of things. You're like, okay, who needs sensors, right? Just spies? No, you use more sensors every day than you would think. And it also is used for some other really cool stuff. So you can use it to measure position, speed, ignition timing in your car, anti-lock brakes, all kinds of things, Hall effect thrusters in some spacecraft, and magnetometers. That's right. Those things at the airport you walk through, those things you see with guys on the beach that are out there looking for buried stuff in the sand. Magnetometers are essentially just an application of the Hall effect. Now, you might look at some of these prizes like this one and say, well, that's simple, right? It's easy. Yeah, but nobody knew it before that. He did this work in 1980. It just wasn't known that if you took the right electromagnetic field and the right conductor that was purified the right way, you put it in the right conditions, boom, you get this voltage, and all of a sudden you can use it to do exciting things. Now, today, this, 2024, about to be 2025, we look at that and go, well, it's obvious, right? Because we've known it for 40 years, 45 years. So to us, it's obvious. But at the time, it was not necessarily something that people thought, hey, let's give this a try and see what happens. It's not the way it worked. So that's it, the Hall effect. It's pretty simple stuff, right? Why it works at an atomic level, we can get into gross details down at like, some graduate level study. But what you're really doing when you apply that electromagnetic field, especially a magnetic field across the conductor, is you're just getting some electrons to start moving around inside there. And when you get those electrons moving around, what you get is a voltage out the other side. So you're just trying to kick off the electron motion. That's all it does. And the result is magnetometers, among other things. So and anti-lock brakes, yeah, cool invention or cool discovery. It was there all the time. We just had to find it. But the applications of it have changed people's lives, and in fact, in this case, saved lives. So we'll try to get to the 1986 video very soon. We'll see you on that one. Don't forget to click like and subscribe and the little bell icon for notifications. Everybody have a great day.